What do you get when engineers decide helicopters can also be airplanes, and then spend 30 years and $27 billion proving it? The result is this elegant monstrosity. It's half helicopter, half airplane, and entirely committed to being the most mechanically complex thing in the sky, while maintaining a safety record that makes everyone nervous. Bell Helicopter and Boeing Vertol teamed up to create the only tiltrotor aircraft actually doing frontline service, and it's simultaneously brilliant and terrifying. Like your girlfriend's Facebook investigations. The V-22's origin story starts with one of the US military's most embarrassing moments, Operation Eagle Claw, the failed attempt to rescue 52 American embassy staff held hostage in Iran in April of 1980. 8 helicopters flew into Iran. Mechanical problems grounded 3 before they even reached the target, and the mission fell apart when a RH-53C Stallion collided with a C-130, killing 8 servicemen. The Pentagon's after-action report was basically a very expensive way of saying, we need to build some kind of Decepticon, half helicopter, half airplane type of deal. Bell Helicopter and Boeing decided to team up and create something that had never been done before at operational scale, a tiltrotor aircraft. The sales pitch was elegant. Imagine being able to rotate your engines forward and cruise at 280 knots like a proper airplane, then land almost anywhere a helicopter can land. The Army also came up with a new aviation unit as a result of the failed Operation Eagle Claw, but we'll save that video for another time. The V-22 Osprey's party trick is that its engine nacelles can rotate 90 degrees, transforming it from helicopter mode to airplane mode in about 12 seconds. When the nacelles point up, it's a helicopter. When they rotate forward, those rotors become propellers, and suddenly you're flying a twin-engine turboprop that can cruise at 280 knots. To put that speed in perspective, most military helicopters top out around 160 knots. The V-22 is nearly twice as fast as the helicopters it was designed to replace. The range advantage is even more dramatic. A Black Hawk has a combat radius of about 300 miles in standard configurations, while the V-22 can self-deploy over 1,000 miles without refueling. This came with an engineering challenge. Those rotors have to work efficiently as both helicopter rotors and airplane propellers. The V-22's rotors have to do both jobs reasonably well, which means they don't do either job perfectly. Then there's the interconnecting drive system, which is where things get really complex. If one engine fails, the other engine can power both rotors through a system of shafts and gearboxes that runs through the wing. The Osprey is genuinely unique in military aviation. There is no other operational tiltrotor aircraft in the world doing large-scale frontline service. Russia has experimented with tiltrotor concepts, but nothing has made it to production. The Europeans have talked about it for decades, but haven't built any. China is reportedly working on tiltrotor technology, but they're still in the trying to figure out how this works phase. The operational flexibility is unprecedented. The Osprey is flown by 3 branches: the Marine Corps, Air Force, and Navy. The Marine Corps can launch V-22s from amphibious assault ships and insert troops deep inland without needing intermediate refueling points. The Air Force Special Operations Command uses them for long-range infiltration or resupply missions, as well as search and rescue. The Navy just recently adopted them for fleet logistics. The V-22's most irreplaceable capability is its capacity to launch from amphibious ships and deliver troops directly to objectives hundreds of miles inland. This fundamentally changes how amphibious operations work. Traditional helicopter assaults required ships to move close to shore, exposing them to coastal defense systems, or establish forward staging areas where helicopters could refuel. The V-22 eliminates both requirements. V-22s have demonstrated the ability to fly from ships in the Pacific to objectives hundreds of miles inland, a distance that would require refueling for traditional helicopters. For special operations, this capability is transformative. Teams can be inserted hundreds of miles behind enemy lines, conduct their mission, and be extracted by the same aircraft that dropped them off, all without requiring intermediate bases or refueling points. there is an elephant in the room. The V-22's early safety record was genuinely terrifying. April 8, 2000, Marana, Arizona, a V-22 crashed during training, killing all 19 Marines aboard. The aircraft had entered vortex ring state, a condition where the aircraft descends into its own rotor downwash, causing rapid, uncontrollable descent. The V-22's large rotors and heavy weight made it particularly susceptible. December 11, 2000, New River, North Carolina. Another crash killed all 4 crew members due to hydraulic system failure caused by vibration-induced chafing from an adjacent wiring bundle, which led to a leak in the hydraulic line. The investigation revealed that the V-22's complex control systems could create situations where normal pilot responses to emergencies would exacerbate problems rather than solve them. June 13, 2012, Eglin Air Force Base, a CV-22 crashed, killing all 5 crew members after experiencing hard clutch engagement, a mechanical failure in the drivetrain that caused violent vibrations and loss of control. The mechanical complexity that makes the V-22 capable also makes it dangerous. The prop rotor gearbox operates under enormous stress and must maintain perfect synchronization between rotors. Any failure during helicopter mode flight is likely catastrophic. Training improvements since the early 2000s have significantly improved the safety record, but the fundamental challenge remains. The V-22 operates in a flight regime that no other aircraft occupies. Despite its troubled safety record, the V-22 has accumulated an impressive operational record. In Iraq and Afghanistan, Marine Corps MV-22s revolutionized troop movement and logistics. The speed and range advantages meant Marines could respond to situations hundreds of miles away within an hour. The long-range medevac capability proved particularly valuable. V-22s could fly directly from forward positions to major medical centers, cutting hours off transport times. Air Force Special Operations CV-22s have conducted numerous classified missions, but unclassified operations provide glimpses of their capabilities. During the 2011 Libya intervention, CV-22s conducted long-range infiltration missions impossible with conventional helicopters. Humanitarian operations have showcased the aircraft's ability to rapidly deploy from ships or distant bases to deliver supplies and evacuate personnel from areas inaccessible to other aircraft. The Army's Future Long-Range Assault Aircraft program represents the next evolution of tiltrotor technology, and Bell's V-280 Valor won by essentially fixing everything that makes the V-22 mechanically complex. Instead of rotating entire engine nacelles, only the rotors and gearboxes tilt, while engines remain fixed. This reduces some hydraulic and mechanical complexities. Many Army aviators still raised eyebrows seeing their branch buy an aircraft that looks so similar to the one they have seen crashing on the news a few times. Strategists have apparently reckoned that the ability to conduct deep air assault operations will be vital in a future conflict with a near-peer adversary. Covering longer distances without refuel sounds good, but I imagine such operations will have to be very coordinated between branches to maintain survivability. The V-280 promises similar performance to the V-22 while being significantly easier to maintain. Bell claims 2.5 times better reliability than current rotorcraft. However, the V-280 won't replace the V-22. It's optimized for Army requirements, not the specialized missions that Marines and Air Force Special Operations conduct. The V-22 Osprey will remain in service well into the 2040s, partly because it occupies operational niches that other aircraft struggle to fill. The Navy's carrier onboard delivery mission requires an aircraft that can operate from any ship with a suitable landing area. Marine Corps amphibious operations remain dependent on the V-22's unique combination of speed, range, and vertical landing capability. The program costs over $27 billion in development, plus unit costs approaching $90 million per aircraft, also create institutional momentum to keep flying. Whether its capabilities are just too difficult to replace with another aircraft, or the military just wants to get its money's worth, leave a comment below. The V-22 Osprey represents both the pinnacle of rotorcraft engineering and a cautionary tale about complexity in military systems. The aircraft succeeds because it creates entirely new operational possibilities, allowing missions that were previously impossible. The V-22 proves that sometimes the most advanced solution is also the most complicated one. It's simultaneously the most capable vertical lift aircraft ever built, and a reminder that engineering brilliance doesn't always translate to operational simplicity. It's America's most unique military aircraft because nobody else was crazy enough to make it work. Subscribe to Steel Mallard for insights into the machines that make everyone nervous, some even for their own operators. See you in the next one.